Embeddable Boundary Condition Independent Reduced Order Model, or Embeddable BCI-ROM technology, makes it possible to achieve predictive accuracy in static or transient system level thermal analysis without the internal specifics of the physical detailed model. In this video, the workflow to create and then use an embeddable BCI-ROM in a system-level design is demonstrated. To create an embeddable BCI-ROM, first the detailed model. A Simcenter Flotherm model of a system-on-chip in a flip-chip ball grid array package. The various components of the BGA model include the solder balls. In this model, the solder balls are represented as a bounding volume with composite material with an air block in the centre. Then there's a substrate, the thermal cover assembly, flip chip bumps, and the die assembly. There are 6 discrete active areas on the die with probes to report internal temperatures. The embeddable BCI-ROM physical envelope is determined by the boundaries present within the model. To capture the footprint area of the cover and solder ball bounding volume, volume cutouts are used with ambient conditions attached. Ambient conditions are also attached to the solution domain faces with explicit labelling of the top and board surfaces. For embeddable BCI-ROM export, the model is set to conduction only. To export the embeddable BCI-ROM, the embeddable BCI-ROM option is selected. Options include the ability to include heat source geometry and probe locations. Every embeddable BCI-ROM will allow the specification of any power profile and will report all probe temperatures, but the ability to visualize size and location are specified with these settings. Other inputs to the embeddable BCI-ROM export are the heat transfer coefficient range the model will be validated against, and the relative accuracy desired for the embeddable BCI-ROM. Once the embeddable BCI-ROM has been created, it can now be used in any system-level design in Simcenter Flotherm. The Simcenter Flotherm model currently has 15 embeddable BCI-ROMs, with an additional one to be imported for the CPU. The embeddable BCI-ROM is imported through the Smart Part interface. The model consists of the solid volume, heat transfer faces, sources, and probes. The author of the embeddable BCI-ROM determines the visibility of the sources and the probes. The property sheet displays the heat transfer coefficient range specified during extraction. Power is assigned by attaching source attributes to each source present in the embeddable BCI-ROM. The model is now ready to solve. Tabular post-processing of the embeddable BCI-ROM includes surface and probe temperatures. Surface temperature plots of embeddable BCI-ROMs can also be created.